One. Today I'm going to show you how to use statcrunch to find the correlation coefficient and do hypothesis testing about whether two variables are linearly correlated. So for this data set shown here, it is actually on page 2 of the chapter 10 slides. It is about paired shoe height data. So it's about 5 males. The first row is the shoe print. The second one is the height. So if you want to find the correlation coefficient, you can say go to statcrunch. For this one, I manually copy the data here. But for other cases, you can find a way to really copy your data in statcrunch. So if you go to stat, regression, simple linear, so this tab is actually used to get the linear regression equation. And the R calculation is also here, just as like a byproduct. Okay, so your X is variable number 1, and Y is variable number 2. And here you just use the by default value and compute. So this will give you a lot of information about linear regression. So what up now you are going to only use is first find your R. This one is showing as the big R. The correlation coefficient is this one, 0.5913. Okay, and this RSQ is R squared. So simply this value is the square of this 0.5913. Okay, and if you want to say do the hypothesis test to see whether your two variables are linearly correlated, one method is you read your R from here, and then you use your table A5 and then see whether your little r is in the critical region or not. That's one method. Another method is using the p-value method. That is, you directly go to this line here, slope, okay, this line. And for this line, you will have the t statistics and the p-value, okay? So this t statistics and p-value are used to test whether those two variables are linearly correlated. So what you do is, say, compare this 0.2937 with your alpha, say 0.05. And this p-value is clearly bigger than 0.05. So p-value bigger than alpha, you fail to reject the null hypothesis. So you cannot say that X and Y are linearly correlated. Okay?